For this video, we're looking at how to use partial fractions to integrate different kinds of functions. So I'm going to start with just the simplification of a fraction. If you had been asked to subtract these two fractions, the first thing I know is that we need a common denominator. And to get that common denominator, I'm going to take my two denominators and multiply them together. So my new denominator will be x plus 7 times x minus 3. Well, that means that for these fractions to both have these denominators, I need to change them individually. So this fraction has the x plus 7, but it needs the x minus 3. So I'm going to have to multiply top and bottom by the x minus 3 for that to happen. So this 5 has to be multiplied by x minus 3. The 2 is going to be need to be multiplied by the x plus 7. So minus 2 x plus 7. And this is the subtraction of those two fractions. Now I could simplify this down. I can distribute my 5. So I have 5x minus 15. Distribute the negative 2. Negative 2x minus 14. And my numerator will be 5x minus 2x, which is a 3x, minus 29. And then the denominator is the common denominator, so x plus 7 times x minus 3, which is fine, and I could write that here, or I could actually FOIL that, and I could get x squared plus 7x minus 3x, so plus 4x, minus 21, which is great. The problem people have is not in integrating this, but what if you start with something that looks like this? How do you integrate that? Well, use substitution is tempting because you can see you've got a higher power in the bottom. We know we can use logarithms to integrate when we have fractions like this, but if this was use substitution, my u would equal x squared plus 4x minus 21. So my du would be a 2x plus 4 dx. There's no way by multiplying or dividing by a number to get a 3x minus 29 out of 2x plus 4. So this is not use substitution. Now let's say that we were actually looking at fractions like this. I said this was easier to integrate, so let's look at that. For this problem, they're similar fractions, they're not the same, but remember you integrate term by term. So I'm actually going to integrate 7 over x minus 2 dx minus the integral of 3 over x plus 5 dx. And both of these are use substitution, but these are easy use substitution problems. For this one, u equals x minus 2, so my du equals a 1 dx, everything's fine. This one is u equals x plus 5, my du equals 1 dx, everything's fine. So this is integrating a 7 over u, and this is integrating a 3 over u. Well, I know that the integral of 1 over u du equals the natural log of the absolute value of my u plus c. So this will equal 7 times the natural log, the absolute value of x minus 2. And I'm going to subtract 3 times the natural log, the absolute value of x plus 5 plus c.